Hello again. These will be the notes for 4.3, Graphing Using Intercepts. There is a PDF available if you'd like to download it and follow along with the notes. First thing we're going to talk about is what is an x-intercept and what is a y-intercept. Quite simply, the x-intercept of a graph is the x-coordinate of the point where the graph crosses the x-axis. It's always indicated in ordered pair form as a, 0. This is very important that at the x-intercept, the value of y has to be 0. If we look over here at the picture, we got an x here, which means our x-intercept occurs there, and notice that our y value at that point is 0. So the a value simply stands for some number followed by 0 to find the x-intercept. The y-intercept is the y-coordinate of the point where the graph crosses the y-axis, and that's always indicated in ordered pair form as 0, b, and the x-coordinate is a 0. So if we look on our y-axis, the y-intercept occurs right here, and you'll notice that the value of x at that point is 0. So 0 followed by a number for y. And that is really what x and y-intercept are, just a point where the x or where the line crosses the x and y axis. Something here that's really important, a lot of people overlook, and we've already said it in the previous page. The x-intercept always occurs when the value of y is equal to 0. So if we want to find the x-intercept, we simply substitute y with 0 and solve for x, and that will give us the x-intercept. The value of x needs to be 0 when we're solving for the y-intercept. That y-intercept will occur only when x is equal to 0. So to find the y-intercept, we substitute x with 0, and then we solve for y. The first thing is find the x and y intercepts of this equation. This equation has been written in standard form. So again, the x-intercept only occurs when y is equal to 0. So we're going to put a 0 in place of y, and 2 times 0 is 0, so effectively the y is no longer in the problem. We just solve for x now. Divide both sides by 3, and we get an x-intercept that is equal to 2. And if I want to know where that was on the graph, it would be 2, 0, because I substituted 0 in for y. Want to solve for the y-intercept? Well, that only occurs when x is equal to 0. So we're going to take a 0, put it in place of x, and 3 times 0 is 0. So effectively, the x drops out of the problem. Move that over a little bit because the sign out in front of the y is important. It's a positive 2. So now I just solve for y by dividing both sides by 2, so my y-intercept ends up equaling 3. And if I want to know what point that was, remember I put a 0 in place of x. So the coordinates on the graph would be 0, 3, and the other one for the x-intercept would be 2, 0. Now in order to draw a straight line, according to geometry, we need only 2 points. Well, the x-intercept is a point on the graph, and the y-intercept is a point on the graph. Once I find both those points, all I got to do is use a straight edge and draw my straight line. Here's an example where we actually graph using the x and y intercepts. The x-intercept. Remember, the x-intercept is when y is equal to 0. So all I'm going to do is cover up the y and now solve for x. So I need to divide by a -3, and that makes my x-intercept equal to positive 5. So in order to graph that, I just go find the x-axis, which is here, and put a point at positive 5. 1, 2, 3, 4, and 5. That would be my point right there. In order to solve for my y-intercept, I simply cover up my x and solve for y. So I'm going to divide by 5, and actually I'm going to change that color to red. Divide by 5. And I get a -3 for my y-intercept. This is my y-axis. Go find -3 on the y, and that would be down 3 places, which would be here. And then all I got to do to graph is take my point see if it'll let me. There we go. Take my line it up on one point, and then draw it so it goes through the other point. And again, this is supposed to have arrowheads on either end because it is drawing a line infinitely in opposite directions. And keep in mind that any ordered pair, any x and y actually on the line, any point on this line, no matter where it is, will end up being a solution for the original problem, which was negative 3x plus 5y equals negative 15. And that's how we graph it. Next one is they give us the graph and then they ask us to find the x and y intercepts. Well, again, this is the, oops, that's not the y, that's the x. It's the x-axis over here. And right here is the x-intercept, and the coordinates of that point would be 2, 0. So the x-intercept would simply be 2. And then I go over to my y-axis. I find where it crosses the y, which is right here. And the coordinates at that point would be 0, 1, 2, 3, 4, 5. So my y-intercept would be positive 5. And that's how you can find the x and y axis, simply by looking at a graph. This is just another reminder that we let A stand for the x-intercept and B stand for the y-intercept. Example 4, you're helping to plan an awards banquet for your school. You need to rent tables to seat 180 people. Tables come in two sizes. Small tables seat 4 people and large tables seat 6 people. This situation can be modeled by the following equation. 4x plus 6y is equal to 180. X is the number of small tables, y is the number of large tables. What they want us to do is find the intercepts, graph, and give 4 possible combinations. Okay, find the intercepts. To find the x-intercept, the x-int, we are going to cover up y and solve for x. So 180 divided by 4 gives us an x-intercept of 45. Now to solve for the y-intercept, I'm substituting a 0 in for x, which means I'm really just covering up the x, and solving for y. So 180 divided by 6 gives us a y-intercept of 30. Next thing they want us to do is actually graph that. In order to graph that, I'm going to have to go by 5. So I'm going to go 5, then put a 10 here, 15, 20, 25, 30, 35, 40, 45, 50 on my x. And I'll go by 5s on the y's. 5, 10, 15, 20, 25, 30, 35, 40. Don't have to go any higher than that. So plot my points. My x-intercept occurred at 45, which would be right here. And my y-intercept occurred at 30, which would be right here. Now I'm going to take my line and connect the dots right about like this. Maybe move that up a little bit. Yeah, we're probably right about there. That looks pretty good. And you'll see that that line represents every possible solution that could work for this equation of x and y equaling 180 when times by 4 and 6. They want us to give 4 possible combinations that work. Now remember, we're talking about numbers of tables. So we can't have fractional or decimal values of tables. X stands for the small number of tables, and the y stands for the large number of tables. So one place we can look is, let's start with the x's being 0. If I choose 0 small tables on the x-axis, I can actually have this many large tables. So 0, 30, which is actually my y-intercept. You'll see over here I cross the x-axis at exactly 45, which is another combination or another solution of 45 and 0. Those are my intercepts. So I can have 0 small tables followed by 30 large tables, or I can have 45 small tables followed by 0 large tables. Those are two possible combinations. I need 2 more, so all I need to do is look at my line to find out where there are integer intersections. So it looks like right about here I have a point, and somewhere else. Where else? Looks like right about here. So it looks like I have 2 more points. So what are the values at those points? Well, I have an x of 30 and a y of 10. And at this other one, I have an x of 15 and a y of 20. So it looks like I have 2 more. Remember, this is the small table, large table, small table, large table. It looks like 15, 20, small, large, and 30, 10, small, large.